Hey there, I'm Heather from the ASPE Consortium, and today I'm going to do a quick couple minutes on attributes that we like to use for salt and shale diapirs. So here we're looking at an image on the left of the seismic amplitude co-rendered with coherence, and you can see the salt diapirs in both directions, both the vertical slice and the time slice. Overall, we find that using those geometric attributes are really essential for defining where the salt bodies are and also the intense kind of fault networks that radiate from the salt and shale diapirs. You can also use curvature attributes to highlight folds, flexures, and the more fractured zones. And of course, co-rendering these geometric attributes is a pretty essential tool for visualizing. So here let's zoom in a little bit on those salt diapirs in the Gulf of Mexico, and we can see now in grayscale the seismic amplitude in kind of a vertical slice and the coherence in a time slice, so a chair display. And what we can see is that the coherence does a really great job of imaging some of those more intricate details that you might miss in the seismic amplitude, highlighting the presence of salt, and you can also even see what the mass transport complexes look like in both the seismic amplitude and the coherence. To take it up a notch, you can also co-render your coherence with your reflector convergence, and so that's happening on the time slice here, which provides a more detailed visualization of these structures. Okay, and now we're looking at a shale diapir in offshore Nigeria, and we've got the vertical seismic section that shows the coherent reflectors kind of within that shale ridge. And now in that same section, we are looking at a phantom horizon slice at 1725 milliseconds below the seafloor, and we can see here in the coherence that we're picking up more complexity of the structures, as well as the distribution of these shale diapirs. Zooming in a little bit, we can now see at two different time slices the radial faults at different depths, which are really crucial for understanding the structural dynamics and evolution of the shale diapirs in this region. And so I want to mention here that running these coherence volumes just takes a couple of minutes, so it can provide you with so much more insight really quickly. I hope these two examples really quickly showed you what can be done in a matter of a few minutes, whether you're looking at shale or salt diapirs. There's a lot more examples and a lot more information on our website if you still have questions and want to explore this further.